Good? Okay, so you can see that there's a little submarine in there, a little remote control submarine. Now, you can also start to see that if I set this to about here, what's going to happen is there's currently two pulses going on, two frequencies being shown here. The first, the blue, is the pulse that this PIC24 is sending to the servo in order for it to know what position to make the finger. Now, why am I wearing this thing? Well, this glove, actually, based on the resistance of this sensor, it will be able to know what position my finger is in. And we want to be able to make it so that it will be able to bend the finger based on the acoustical signal processing that's happening through here. It's very hard to control things with radio frequency, so while that submarine is not currently being able to be controlled by my acoustics based on my finger flex sensor here, right now we're demonstrating that I can control, because I don't have any waterproof things right now that I've actually made rather than commercially bought, that this can use acoustic signal processing, because out in terms of out in the ocean, radio frequency type of devices are not going to be able to actually work with anything other than acoustics. So we're showing acoustic signal processing actually works. Now, if I put this in here, if I put my little finger sensor in here, what's going to happen is it's going to be able to read a certain frequency from here, right? So based on the position that I make my finger, we can broadcast a certain frequency correlated to the robotic hand that will match what I'm doing to show intention through acoustic frequency. Now you might say, with this, right, while it's making those frequencies, great, but there's going to be a bunch of fish swimming around in the ocean. There's going to be a lot of acoustical noise. Well, what you can actually do is you'll be able to find certain frequencies that will work when there's a lot of other acoustical noise going on. So if you see down here, even while this little submarine is making a ton of different noise that you can also see in the water, the frequencies that have been chosen make it so that they are not interfering acoustically, because that submarine is making acoustic noise in the water, and even with that noise, the frequencies that have been chosen will not be interfering, will not receive interference that blocks it. So even with the acoustical noise going on, the frequency is chosen, as you can see the orange moving to different degrees. We'll still be able to do that type of communication even with lots of noise in the water. So pretty useful in terms of when we're going to have drones fly out 150 miles, and there's going to be these little submarines that aren't going to be RF controlled, because RF control doesn't really work way out in the ocean with all different types of water. So dropping a little buoy, a little ball from a drone, as well as a little submarine that's going to be acoustically controlled, the buoy will, the top of it, be able to grab cellular radio frequency that will broadcast down to the buoy, and the buoy will make the acoustic signal processing via like a bridge between cellular and acoustic signal processing. So you can send a drone out that will have a non-radio frequency little submarine that will listen to the acoustics, and you can use that in terms of disarming explosives that are far out there, because you're not going to be able to send a little submarine like that, put it in the shore and send it out 150 miles. So flying it out with a drone that drops a little buoy bridge that can take the cellular to acoustics, that thing drops in there, you can use acoustic signal processing. Even with lots of noise in the water, it will still work based on the frequencies that you choose. And then you can start to use frequency signal processing in terms of how we've looked at encoding the different messages. So when you encode the message, you can have a ton of different frequencies, as you can see here. You can have a whole frequency table where you're able to send start frequencies. Hey, I'm doing this type of encoding. It's asynchronous. You wait for the PIC24, which is controlled on this breadboard right here. This is how it's receiving the acoustic signal. Now it has an analog input, which doesn't like negative alternating current. So there's also an op amp here that has a DC offset in order to raise the frequency of the AC, as well as amplify the signal, because it's going to be a tiny acoustic, so it can use analog signal processing to actually map the signal and the frequencies that's happening And then instead of having a frequency for every single finger's different positions, you can have certain encodings where as you say start, it says okay, you wait for that, then you pick, hey, I want to choose this finger, it responds with okay, and then you set a position, hey, this position. Those positions can apply to all the different fingers and all whatever it is that you're going to end up being controlling, because you're probably not going to control a hand in the ocean, but the idea of the robotics is the same. Now, what happens if you don't have all of those different frequencies available in the water for whatever reason? Maybe something will end up interfering with it. Well, initially when it starts, it's going to do a frequency sweep, and from the frequency sweep, you're going to see, hey, are all these frequencies available? And if some of them aren't, well, you don't want to be able to not, like, for example, control the finger, control the middle finger, but you can control everything else. That doesn't really work. So if not all the frequencies are available, it will look at the top 3 frequencies, and then of those ones that are the strongest, it's going to be able to set a, one of those frequencies is going to be represent a bit of 1, the other one will represent a bit of 0, and then the other one will be an acknowledgement from the receiving device. So then it will just send maybe a byte or a couple of bytes in the encoding, and it's going to wait as it's sending bit by bit and then waiting for the acknowledgement. Once the receiving robot will receive enough bits, you'll have a full byte and it can process whatever that is. It's kind of like signal processing for, let's say, your phone having 5G or 3G or 4G. It really wants 5G for the best data transmission, but it looks at what's available. So if 5G isn't available, you're going to switch to 4G or 3G. So if you're not going to have this frequency encoding here, then if that's not available, then you're going to switch to the equivalent of sending bits with just a couple of different frequencies. So I tried to make that go fast so that it wasn't taking forever through it, so hopefully that was interesting and cool, and yeah. Thanks.